In this video, we're going to look at solving a pair of simultaneous equations using the elimination method. So the elimination method is really just about, exactly as it says, eliminating a variable of our choice. So let's have a look at this example. So we've got 2x plus y equals 6 and x minus y equals negative 3. We want to come up with a solution, in other words, a value for x and a value for y, so that when I substitute them into both of these equations, so 2x plus y equals 6 and x minus y equals negative 3, both equations hold true. Okay, so look, I guess if we were just looking at one of these equations, there's an infinite number of answers. So if I could have, for example, x equals 0 and y equals 6, that would work for the first equation, but it certainly would not work for the second equation. So what we're going to do is simplify this set of equations. We're going to reduce these two equations into one equation by eliminating a variable, and then we're going to end up with just one equation with one type of variable, either an x or a y variable. So first of all, just ensure that the variables are lined up under each other. So we have, in this case, the x variables there in one column. We have the y variables in another column, and we have the constant terms in a third column there. Equal signs are also lined up too, just to sort of keep it neat and tidy. Now let's choose a variable to eliminate. Identify the variables that are identical, and that also includes the coefficient. So we have 2x in the top equation lined up with just x on the bottom equation, so these are considered different. We have the y variables. We have a plus y up the top here. We have a minus y down the bottom here. Now that's close enough to identical, so we can eliminate the y variable. Okay, they don't have to be the same sign. So one could be plus, one could be minus, it doesn't really matter. And the constant terms, all that doesn't really matter. So don't worry too much about them. The next thing we do now is to identify whether we add the two equations together or subtract them one from the other. And that really depends on the sign of the variable we've chosen to eliminate. So we've chosen to eliminate the y. So how do we do that? So we've got plus y and a minus y. Now, if we add those two together, so plus y plus minus y, they eliminate. So let's add those two together, those two equations together. So 2x plus x is 3x. Positive y, so probably better to say that actually. Positive y plus negative y. Okay, so I might just write it here. So if we had, for example, plus 2 or positive 2 plus minus 2, 2 plus minus 2, well, that gives you 0. So that eliminates those two. So that's really what we're doing here, except we're using algebra or algebraic terms instead of just numbers. So that'll in fact be 0 is equal to 6 plus negative 3, which is the same as 6 minus 3. So that's going to be 3. Okay, so solving that, we have x is equal to 1, okay, by dividing both sides by 3. So 3 times 1 gives you 3. That's not our final answer though. We also need to find the value of y. So what I might do is I'm just going to label these two equations. So we've got equation 1 and equation 2. We can choose either one of these two equations to substitute the x equals 1 into one of those two, and then to find the remaining variable. So let's use equation 2 only because sort of it looks simpler. So from 2, okay, we've got x minus y is equal to negative 3. Now we have x equals 1, so 1 minus y is equal to negative 3. Let's move the y over and move the negative 3 over. So we have 1. Now moving the negative 3 over becomes positive 3, and moving the negative y over becomes positive y. And that's easy enough. Y is in fact equal to 4. So these are in fact our two solutions. So therefore, x is equal to 1, y is equal to 4. Now, one last step, and you should try and factor in a little bit of time. Check to make sure that this solution in fact works for both of these equations. So if x equals 1, y equals 4, okay, so 2 times 1 is 2, plus 4 equals 6, so that's correct. What about the second equation? 1, so x equals 1, 1 minus 4, so substituting the 4 in here for y, 1 minus 4 Well, certainly equals -3. So I'm satisfied that this is in fact the correct answer for this set of simultaneous equations.